take a look at this problem. We got f of x is equal to x to the third minus 3x plus 2. First thing is a domain. Well, since we're dealing with a polynomial, our domain is negative infinity to positive infinity. Next thing we'll find is the x-intercept. To find the x-intercept, you always plug 0 into the other variable. So to find the x-intercept, we'll plug 0 in for y. So we got 0 is equal to x to the third minus 3x plus 2. And we're going to use the intersect method to find this. So I go to y equals clear. And we got x to the third, so I'll do x caret 3 minus 3x plus 2. And have to have 0 on y2, so I'll down arrow, and if you don't have 0 here, put a 0 there. I had 0, but now I'll do second trace, choose intersect. Looks like negative 2, so we do inner negative 2. Yep, that looks like one of them. The other one looks like 1. So let me do it again. Do second trace, choose intersect, enter 1. And those would be our x-intercepts. This is our domain. C, our y-intercept. Well, we'll plug 0 into the other variable, so we're finding the y-intercept, so we'll plug 0 in for x. So we've got y is equal to 0 to the third minus 3 times 0 plus 2. 0 to the third drops away, 3 times 0 drops away, so that gives us y is equal to 2. What is D? D is vertical asymptote. Well, there is no vertical asymptote. You only have asymptotes when it's a rational function. Let's see, E. Horizontal asymptote? None. F. Slant asymptote. And that would be none. Again, you don't have any asymptotes unless you have a single fraction, rational function. G. Intervals of increasing and decreasing. Well, let's find our derivative. So f prime, x to the third becomes 3x squared minus, and derivative of 3x is 3. Now I want to find our critical value, so we'll set this equal to 0. So I got 3x squared minus 3 equal to 0. I'll factor out the GCF. So I'll factor out a 3, and that gives us x squared minus 1 equal to 0. Well, now it's difference two squares, two terms of minusing it. And this factors as 3 times x plus 1 times x minus 1 equal to 0. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. Now it doesn't do us any good to set the 3 equal to 0 because there's no x to solve for there. But we got x plus 1 equal to 0 and x minus 1 equal to 0. So we got x equal negative 1 and x is equal to positive 1. Now we want to build a table of intervals. Clear over here is on negative infinity. Clear over here is positive infinity. We want to choose test cases. Something between negative infinity and negative 1, like negative 2. Something between negative 1 and 1, like 0. And something greater than 1, like 2. Now we want to plug those into our first derivative. Our first derivative is right here. Well, if I put negative 2 in here, negative 2 squared is 4 times 3 is 12 minus 3 is positive, so this is increasing. If I put 0 in for x, 0 squared is 0 times 3 is 0 minus 3 is negative, so this is decreasing. If I put 2 in, 2 squared is 4 times 3 is 12 minus 3 is 9. It's positive, so it's increasing. So it's increasing from negative infinity to negative 1. Then it's decreasing from negative 1 to 1. And then it's increasing from 1 to positive infinity. Well, H should be extrema. Yeah, min, max. Our minimum, maximum occur when the increasing, decreasing change. Here it's increasing, changes to decreasing, so there's going to be a max. This one changes from decreasing to increasing, so there's going to be a min. So we're going to have a max at x equals negative 1, and we'll have a min at x is equal to 1. Now we want to plug those back into our original function. So, and remember f of x is y. So we've got y is equal to negative 1 to the third power minus 3 times negative 1 plus 2. Negative 1 to the third is negative 1. Negative 3 times negative 1 is a positive 3 plus 2. Negative 1 plus 3 is 2. 2 plus 2 is 4. So we're going to have a max of negative 1, 4. I don't really have room for the min there, so let me come down here. Again, we're going to plug that into our original function. So we've got 1 to the third minus 3 times 1 plus 2. 1 to the third is 1, plus 2 is 3, minus 3 gives us 0. So we're going to have a min at 1, 0. Well, probably concavity, yeah. For the concavity, we need our second derivative. So our first derivative is 3x squared minus 3, so I take the derivative of that. Negative 3 drops away. Derivative of 3x squared gives us 6x. Okay, well, we want to set that equal to 0 and solve. That'll give us our critical values. Here I'll divide both sides by 6. And 0 divided by 6 is 0. And then we'll do our intervals. Clear over here is negative infinity. Clear over here is positive infinity. I will choose test cases, something between negative infinity and 0, like negative 1. Something between 0 and infinity, like 1. Now we want to plug those into our second derivative, which is 6x. So I got 6 times negative 1 and 6 times positive 1. 6 times negative 1 is negative, so it's concave down. 6 times 1 is positive, so it's concave up. So this is on concave down from negative infinity to 0. And then it's concave up from 0 to positive infinity. Now J. Find our inflection points. Our point of inflection occurs where the concavity changes, assuming the point exists. It's concave down here, changes concave up, so this is a POI. So we got a POI at x is equal to 0. We want to plug that into our original function, which is x to the third. So I got 0 to the third minus 3 times 0 plus 2. Well, 0 to the third drops away, 3 times 0 drops away, and we get y is equal to 2. So we have a POI at 0, 2. Okay, our graph. Let's see. X-intercept is at negative 2, 1. So negative 2, 1. Our y-intercept is at 2. It's right there. Our max is negative 1, 4. So negative 1, 4. And our min is at 1, 0. So 1, 0. This would be our min. Okay. Well, originally our graph is increasing, changes decreasing, so it increases up to -1. So it's going to increase up to there, then it's going to decrease from -1 to 1, so it's going to decrease down to here, and then it'll increase from then on. Okay, so I have an idea of what's going on. It's probably going to be as good as I can sketch it. So it's increasing, increasing, hits this point. It's a max, so it has to start going back down. So it's decreasing, decreasing. It's this point. This is a min, so it starts increasing, changes. And that's our graph. Now, again, you don't have to sketch it for the homework. You can just plug in your calculator. All the different pieces is kind of the important part of what I'm looking for. Okay, so I'll go to y equals, press clear. And I got x to the third, so I do x caret 3 minus 3x plus 2, and then graph. You'll see a much better picture there than what I came up with down there. Mine's a little bit too straight in the lines, but as good as I'm going to do by hand. So those are our answers.